Hi there. Today I'm going to see net present value, which is the third method, and this only applies to the HL students. Now for NPV, I'm going to call net present value as NPV, you would need discount tables. So along with your other formulas that you get given in exams, you also receive the discount tables, okay? So this method is the best of all the three methods. What it actually tells us is you make a prediction that machine A is going to give you in a year's time $50,000, and in 5 years you're going to get, in year 5 you're going to get $100,000. But what happens to the value of money is that a dollar today is not the same in 5 years' time. So we've got what's called the present value tables. The way we do that is there's this formula 1 over 1 plus r raised to the power of n. So you're trying to ascertain what's the value of a dollar at a particular rate of interest, discount rate of interest, in n years. So a lot of bankers and investment bankers, the like, use this to compound their interests. Okay, so ascertaining the correct value of a dollar is the most rational way of arriving at decision. So with that in mind, let's assume that for this question, now in exams you will be stated the discount factor for the questions that you are given. So for this question I'm going to assume 6%. Okay, so what's the dollar worth today at 6%. So if I were to do this after 1 year's time, I'm going to get the answer as 94.9434, which means that 94 cents today, 94.34 cents today, when invested at 6% discount rate, after a year is going to give me $1. Okay. Likewise, if I were to do this for 2 years at the same discount rate of 6%, I'm going to get 89 cents. So 89 cents is what I have to invest today to get in 2 years' time $1. Okay, so this tells us the correct value of money. So 89 cents is what I'll be actually getting today, the $1 that I would have received in 2 years' time. So this is a bit difficult. I'll explain it later there. So this particular operation that we've just done here in terms of ascertaining all these 0.9434s and all that is actually given to us ready-made in exams. So we've got these discount tables that you get in exams. So it looks at 4%, 6%, 8%, 10%, 20%. Got these 5 discount rates, and you've got for 10 years. In exams, you'll only get from these any of these 5 discount factors, and it will be for 10 years maximum. Okay, so you got to use this. So I've got the 6% here, which I'm not going to find out for each, because these values that I obtained through this formula is what is already there. Okay, so now with this background knowledge, let's now do NPV. I'm going to take the 6% discount factor. I'm going to write this down. So all I'm going to do is I'm going to copy against 6% for the first 5 years their respective discount tables. Okay, that's all I'm going to do. That's all you have to do. It's very easy. Okay, so you just have to copy down the 4 digits. Do not round this off, because we need to keep it 4 digits like that. If you round off, then your answers will be very different and it will be wrong and you might lose marks. So keep it to 4 decimal places. So I'm going to multiply this. So all I've done is I've taken the cash inflows and I've multiplied the 6% discount factor, and I'm going to write the present values. I've already done the maths here. I'm simply going to copy it. You have to be very careful when you're multiplying it, so you don't look at other numbers as you're multiplying it. And the last one is 82, 190. So these are the present values. So what it actually means is that, let's take random 3, year 3. You expect to receive in year 3 on machine A $200,000, right? But it's not $200,000 that you're going to receive today. You're going to receive that in 3 years. But today, what is it worth? What's the present value of those $200,000? It's only $177,800. Did you see what it actually tells us, the present value? Let's take in year 5. You anticipate that in year 5 you're going to receive $100,000 on machine A. But you want to know, what is it worth today? What is it worth in the present day? So the worth of that in the present day, today, as of today, is $82,190. So what is actually happening is you're inflating. You're trying to show artificial numbers which are much more than what it is worth as of the present. Therefore, the net present value becomes a very, very sophisticated tool for decision making, because it takes into account the discount rates, the true value of money in today's dollars. Okay, so this is the present value. So if you add up, it gives you 571,485. If you were to add this, it would have been for $650,000, whereas you're only getting $571,000. So that's the present value. As of today, machine A will fetch us in 5 years this much value and not what is shown there. It's simply because of the discount factor that we always have to incorporate in decision making. Okay, now, so this is your sum of all the present values. Take out the original cost of $200,000, which is that, the original cost. So the net present value is $371,485. So that's the net present value. Okay, in fact, this formula that I've just written here vertically is stated in the formula sheet as well. It's just horizontally written, but I've written it vertically. So writing in this fashion, in a vertical format, is very easy to articulate, and you can just be very organized. Now, likewise for machine B, I've already done the maths there. All I've done is I've put the same discount rate, 6%. You cannot change, it has to be the same. And I have already found out what the maths are against it. So you multiply the same way. I'm getting that. So I'm going to add this up. Sum of all the present values, it's $1,300,794. Take out the original cost, which is $350,000. So I'm left with $950,000, 794. That's the net present value. Now, for decision-making purposes, you go with the one that gives you the highest net present value, which in this case is for machine B, whereas machine A only gives us about a third of what machine B gives. So investing in machine A is worthwhile for the company. Okay, simply because when you use the net present value, it gives us a higher return. Okay.